Hi, I'm going to talk about the Pigrow's Timelapse tools and how you can write your own script to make it do anything you want. Timelapse is a video made from a series of images taken at regular intervals. When we put them together, it allows us to see things sped up so that movement, which would otherwise be too slow to notice, becomes visible and fascinating. To make a time-lapse, you just need a camera connected to the Pi. There's a range of great cameras that connect directly to the Pi's camera port, or you can use a USB webcam. I'm using a really old Logitech C90 because it's all I have available at the moment. With it plugged in, we can connect to the Raspberry Pi using the Pigrow remote GUI and go into the camera tab. We only have one camera connected, so we can select that and the tool we want to use to take pictures. For the USB webcam, we'll use FSB webcam. To check that works, we can take an image with the default settings and see how it looks. Seems okay. Each webcam has its own internal settings, so we can ask the Pigrow to get a list of them. It will depend on your cam which options show up here, but they probably look something like this. Of course your needs will vary, but I tend to turn off the autofocus, auto white balance and all of those features, setting it where I want so that I can avoid rapidly shifting settings causing flickering or anything that could ruin the final video. We can ask it for a list of supported image resolutions too. As we're taking still images, they can normally use higher resolutions than the streaming video they provide in webcam mode. When we have it creating the best images, then we can save those settings to the Pi and we're ready to start our time-lapse recording. To capture the images for our time-lapse, we want to call the script at regular intervals. To do this, we use cron. I'll soon be adding a tool to set it automatically, but it's already pretty simple. We just need to go over to the cron tab on the remote GUI and add a new job. We're using the webcam, so we want camcap.py, and we're using the default camera config file name, so we don't actually need to set it here, but I put it into the extra args anyway. Set equals camera_config.txt. Now all we need to do is decide how often to trigger the camera. Every 5 minutes is normally the lowest I'd go with plants, but as this is just a short video of seedlings, I'd just try every 1 minute so we've got plenty of frames to play with. With that added, I'll update the Pi's cron file by pressing Save Cron, and it'll start running that script at 1 minute intervals. Switching to the local files tab, we can see that there aren't any yet, so give it a moment. Here's our first image, which we can download onto our local machine. Of course, we can't make a video with a single image, so I'll add some soil to my tray and wait for a few more images to come through. Now when we refresh, there's some more images to work with, so let's download those to our local folder and we'll be ready to start the fun bit, to see what it all looks like. If we switch to the Timelapse tab and press Open Caps folder, then it will load all our images. So if we go press the render button, it will render them into a video for us. Except it won't because I haven't installed MPV yet. That's okay. If we jump to their website, mpv.io, and we just go to the download section and find this script, run it. It looks like it's hacking a 90s mainframe, but it's installing MPV and sorting everything out. So now we can make our time lapse. It's looking okay. It's not very long, so I'll leave the Pigrow watching this while I go and do a bit more programming. A week later, we've got a huge amount of files. I did drop it down to only taking a photo every 2 minutes rather than every 1 minute. And we've still got a lot of pictures. These will take a while to download, so I'll skip to when it's done. We've now got them on our local system, so to reclaim some space on the Pi, we can press Clear Downloaded Caps, and it will remove every file in the Remote Caps folder that's also in the local folder. Again, with over 5,000 files, it will take a while to finish, so skip to the end and then we can go back to the Timelapse tab. When we load the captured image set, you can see in the most recent picture that my crest has grown. It's had a few problems too, so it'll be interesting to see what happened. First though, let's use a couple of the image set analysis tools to check what we've got. The day grid shrinks a copy of every frame and places it on the grid positioned in the time it was taken. It's a lot of pictures it's having to load, so it will take a while, but eventually it will make them into a single image that shows up here and we can click to open it. The pink section on the left is where there are no frames. You can see every day it's dark after 1 AM, which is when my light goes out, and if we scroll down to 8 AM, we can see it turning back on. There's this odd bit on the left where we were taking a picture every 1 minute, but the main section looks fairly consistent, Can't see any missing or majorly glitching frames. For our video, we want to remove the long dark period every day, and as a black frame has very little data, it's a good trick for doing this to ignore any files below a certain file size. We have a set analysis tool we can use to determine the ideal cutoff point. Unfortunately, this version won't work on such a large amount of files, but we'll talk about upgrading these scripts in a moment. For now, we'll just make a set using every second frame and analyse that. It's not the prettiest graph, but we can see most of our images are above 600 kilobytes. Then, if we scroll along to where the dark images start, they drop down to below 100k. So we want the cutoff to be somewhere between those 2 points. If we put 100,000 in the minimum file size box, that cuts the frame count down and shortens the duration of our video. Worth noting now that it's telling us the video will be about 30,000 times faster than reality, though the movement we see will still only be about 20,000 times faster, because it's only calculating using the total times between start and finish, without accounting for the missing 7 hours every day. So let's render that and have a look. You can see the soil getting lighter as it's drying out, especially that left edge. Periodically it darkens when I give it a spray with a water bottle, and eventually the seeds start to sprout, all pushing out the ground together, dancing to find the light. But then I forget to water them and they all wilt. I have since given them a good spray and they're slowly coming back to life. While we leave them to grow a bit more, I'll tell you how the modular system for these tools works. It's actually fairly simple. There are currently 3 modular sections: the image set analysis tool we've looked at, and the frame select options, which we'll look at a little bit later, plus the stylized image set, which I showed in the last video. Each of these is a file in the Timelapse _modules folder with associated prefix stylize _ cell mode _ and analyze _. If we want to make our own analysis tool, then we can start by copying one of the analyze _ scripts and renaming it to something without any spaces or special characters. I'll call it analyze _ test. Then, if we go to the GUI, we can try it out, though it'll only detect it's there when the GUI is restarted, so I'll just type in its name for now. Of course, we didn't alter anything, so it does exactly what the script we copied does, and just draws a basic graph, but we can change that. As long as we keep a couple of key parts of the script the same, we can make it do whatever we want, and if we want, we can even get ChatGPT to do most of the work for us. Sometimes. The scripts for the analysis tool are pretty simple. We need to define a function called analyzeSet, which gets handed a list of paths to each image, and the path where the output image will be saved. The rest of the code can be pretty much anything you want. This one just cycles through the frame list to create a matching set of file dates, then cycles through those, creating the time difference between each frame's date and the first image's date. It then uses matplotlib to create a graph, and all importantly, saves it using the path we got handed with the outFile variable. This also has a function to extract the time string from a standard Pigrow caps file name and convert it into a datetime object. You'll likely need this if you want to do time-based analysis, but let's not worry about that for now. Let's go ask AI for help modifying it. I'm just using the free version of ChatGPT here, so hopefully it's good enough. The same steps will work for any of the coding LLMs. I think I want to see a graph of how many dark pixels there are first, so I'll explain the situation as clearly as possible. I have a Python script which is imported into another program and used to analyze a set of images. I'll include the code below, and I'd like you to rewrite it so it counts how many pixels have a value below the RGB values 25, 25, 25. Then graphs the total amount of dark pixels for each frame and saves the graph just like in the one provided. Then I just paste in the analyzeSet function from the original timegraph script. When I've played around a bit more, I do some testing and work out a good description of the requirements for each of the modules, but I found ChatGPT seems to find it much easier if you provide a full example. Oh, and I had better tell it. The function you create must have the same name and arguments as analyzeSet, and save the output file to outFile. Like magic, distant compute modules zap through some insanely complex algorithms, and we get our response. I'll copy it into the editor so we can see it better. It's added a new function to find the dark pixels, just like we asked. The main function name has stayed the same and it's saving our output graph to the correct location, so that's a great start. I do notice that it's still making a list of file dates, which we probably don't need for this, but if we test it out in the Pigrow GUI then we can see it's all working. And it shows about what we'd expect. There are relatively few black pixels until we get to when the light turns off, at which point the number goes up to around 100%. We can ask ChatGPT not to bother with the file dates list, which should make it a little bit faster. While we're there, I have it deliver the output as a percentage value, just for clarity's sake. This code looks better, so I replace what we had before, and now when we look at the graph it's basically the same, but we can see there's now a small mistake. We asked for it as a percentage, but the maximum value here is 300. ChatGPT will make little errors like this sometimes, so it's important to try and verify it's actually doing what it's supposed to. It's not a big problem though, and we can just politely ask for it to be fixed. There, it's easily identified the problem as because it was using the total values of all three colour channels, and it's written code that should work better. If we copy that in and run the script, then yes, we get the graph that tops out at 100%, just like we wanted. With that working, let's see if we can make it a bit more interesting and try graphing how much green is in the image. I tell Clippy, "That's fantastic, thank you. Now change it so it shows us the intensity of the green pixels in the image." A quick glance at the reply and it's now isolating the green channel and taking an average of all the pixels. I don't know if it will work for what we want, but let's have a look. For this I shifted to a bit in the set where the crest sprouts green leaves, but the graph isn't really showing anything, so let's see if our friend has any suggestions. The code worked great, but the graph wasn't as useful as I was hoping. Any ideas on a graph that would make it obvious when sections of the time-lapse set have turned green? Looking at the code, it's not actually changed how it determines the green intensity, which I guess is on me, because I said the code worked great. The graph now looks a bit better though, so that's nice. Let's try asking for something else. Looks pretty. Can we change how it determines the green intensity? Instead count how many pixels are more green than they are other colours. Try graphing 4 values for each image, a count of how many pixels are 1 to 25% more green than the others, how many are 25 to 50%, 50 to 75% and 75 to 100% more green. This time we see the rising gradient that we hoped for, so that's great. At first I thought it wasn't showing the other 3 bars, but actually, if we look down at the bottom, the values are actually just really low. Maybe I'll experiment a bit more with this and see if I can get anything more interesting out of it, but hopefully you've seen enough to be able to explore your own ideas with the analyse set scripts. ChatGPT can be frustrating at times. If it keeps giving you wrong answers or not doing what you ask, then it could be because it's getting confused with the prior conversation. So start a new chat, rephrase your question, copy-paste in any code that it might need to see. You will need a basic understanding of Python to know where to put the code and what's important. But once you have that, then it can be a great learning tool. Just ask for an explanation of any part that you don't understand, and if you still don't get it, then keep asking questions. At some point, I will probably run a competition to win a Raspberry Pi and sensors for whoever can make the most useful or coolest module for the time-lapse tools. If anyone's been following the project long enough to remember the graph module competition, it will be similar to that, which resulted in us getting some fantastic new graphing options for the Pigrow. So look out for announcements about that. Huge thank you to the Patreons that support the project and everyone that participates in the community. I always feel weird about asking for money, but if you want me to be able to afford better webcams and new gadgets to experiment with, then please consider supporting the project because it really will affect the scope of what I can do. If you can't afford to or have other commitments, then that's completely fine. Your participation in the community and interest in automated gardening is more than enough. Hopefully I have my first dedicated long duration time-lapse box, SageMoss, ready to finally install everything into, and I'll make an update video on that when I finish painting it, so like and subscribe for that and everything else that I've got coming up. Thanks very much.